Hi there, I'm Newman Fakhar. I'm a solutions architect and strategist with IBM, and I believe that big data is changing the world for the better. Today I'm going to show you a glimpse of the kind of big data apps you can run on IBM's next generation cloud platform called BlueMix. So imagine you're a financial analyst who wants to analyze historical market data for a client's portfolio, and you ask your line of business application developer to quickly provide you with some visual tools to do this analysis. Now, the data you want to analyze is 30 years of trading history of every stock on the NASDAQ exchange, which is a lot of data. So you tell your developer that the data set is large, that the data set is unstructured, your deadline to analyze the data set is aggressive, and you may not need to keep the infrastructure or the app around once you're done with your assignment. Upon hearing these requirements, your developer leans towards a Hadoop solution on the cloud and a Ruby on Rails front end that he can iterate on very quickly. Now, IBM BlueMix fits the bill here very well because BlueMix provides a Hadoop service which gives the developer access to a powerful Hadoop cluster within minutes. And BlueMix also supports popular application runtimes such as Ruby on Rails, and the BlueMix Hadoop service can be leveraged by Rails apps that run on BlueMix. Now, we will use real financial market data in this demo. However, please note that I'm not giving professional advice on particular stocks. Neither am I making statements about particular stocks. This scenario is for demonstration purposes only. So, I'm going to take you through the solution backwards, where I will show you the end result that the developer came up with. Here's your Rails app that your developer built. The front end is HTML5, jQuery, CSS, and a couple of visualization libraries, namely D3.js and JQplot. Let's first take a look at a couple of pre-built visualizations of your market data. One of the financial metrics you value as an analyst is stock liquidity. That is, which were the most traded stocks the past 30 years on NASDAQ. And the more liquid a stock is, the faster and safer it is to buy or sell it. And that's what this pre-built visualization is about. It's showing you the most liquid stocks the past 30 years. Now, the Hadoop job behind this visualization calculates the aggregate trading volume of every stock on NASDAQ in the 30-year dataset. We have visualized the output of that Hadoop job with D3.js. You may know already that D3.js is a very popular JavaScript library for writing data-driven apps nowadays. So this is real market data. The larger the bubble, the more liquid the stock is. And we can see that Microsoft was the most liquid stock on NASDAQ these past 30 years. Let's take a look at a second visualization. Another metric an analyst would be interested in would be stock volatility in relation to trading volume and dividends. Now, volatility indicates how much the price of a stock oscillates on an average day. The more it oscillates, the more volatile it is. Let's take a quick look at the sample data and the pig script that calculates stock volatility on the dataset. So here's a sample of the data. Each line includes the exchange, stock symbol, date, and a bunch of prices which represent the opening, high, low, and closing price for that day. It is this data that resides in HDFS. Now, Pig, which is a data flow language and environment for Hadoop, makes it very easy to express grouping of data and then doing aggregate functions on the groups. In this script, we first generate daily volatility for each stock by taking the difference of its high and low price. Then we group all daily volatility data for each stock by its symbol. And this way, for each stock, we have a history of its daily volatility across 30 years. However, we're really interested in the average 30-year volatility of each stock. So we use the average aggregate function to average out the 30-year volatility data for each stock. And finally, we store output back to HDFS. So this should make this demo very real for you. You can see that the demo is doing valuable analysis on real market data using Hadoop. Going back to the visualization, what value can we derive from this chart? We visualized three aspects of a stock on this chart. Liquidity. The larger the bubble, the more liquid the stock is. And on the x-axis, we have volatility. And we just looked at the pick script for volatility. Lastly, we also ran a Hadoop job to calculate aggregate 30-year dividends, which indicates if a stock is good for income portfolios. So if you look at Apple, you can see that it is a pretty liquid stock and it's relatively volatile. So it could be a good candidate for day trading. Whereas News Corp over here pays good dividends, isn't volatile, and isn't very liquid, which makes it a good stock for long-term holding or income-oriented portfolios. So this kind of data-driven approach helps the analyst to justify his stock picks for various client portfolios. So let's spice things up a bit more and look at a scenario where we can choose a bunch of stocks and kick off a Hadoop job on the BlueMix MapReduce cluster from this Rails app. Imagine you as an analyst have some conservative clients who want stock portfolios that remain stable even in recession years. That is, your conservative clients want stocks that have low volatility in recessions. So how do we identify such stocks? We're going to choose 10 stocks from this list and submit a Hadoop job from the Rails app to the MapReduce service running on BlueMix. This Hadoop job will analyze the large 30-year market dataset and will calculate average volatilities of only our chosen stocks in recent recession years. From an integration perspective, this Rails app is communicating via REST APIs to a Hadoop cluster that was provisioned via the BlueMix MapReduce service. The recession analysis is done via a couple of Hadoop jobs, a pig job, an example of which we looked at earlier in the demo, and a Hive job. Hive is a SQL-like query language for Hadoop and is very useful for leveraging existing SQL skill sets in your organization. Now, when the jobs are finished, the Rails app pulls down the results via a REST API from the Hadoop file system and visualizes them using a d3.js heat map. This heat map shows the volatility of our chosen stocks in recent recession years, namely the recessions of 2000, 2001, 2007, 2008, and 2009. The deeper the shade of red in every quadrant, the more volatile that stock was during that time period. For example, if we look at the 2000 quadrant, we can see that Apple, Amazon, and Cisco were relatively volatile in the 2000 recession. If we look at Apple throughout the recession years across the board, we can see that Apple has been relatively volatile in all of the recent recession years, with the exception of maybe 2001, where we see some pink color in the quadrant as opposed to red. Now, if we compare Apple to BOOT, BOOT, by the way, is a symbol for a company called Lacrosse Footwear. We can see that BOOT has been one of the more stable stocks in recent recessions. There's not as much red in any of the BOOT quadrants as compared to, say, Amazon or Apple. So this allows the analyst to choose stocks with particular characteristics for his client's portfolios and to be able to back up his recommendations with data that has been analyzed with Hadoop on BlueMix. This demo was a glimpse of the kind of big data apps you can write on BlueMix. I encourage you to sign up for the BlueMix Open Beta and get a first-hand experience of how powerful this platform really is. Thanks very much for watching.